Hi, this is lesson 10.1. We're taught today about matrices. So a matrix is a rectangular array of any real numbers. Remember, it has to be a rectangle. You're not going to have a matrix that has missing terms in it. So always remember it's rectangular. We talk about a matrix and we always think about the order of that matrix. And we always talk about order in terms of the number of rows by the number of columns. And so that's easy to remember. You can remember that as rice cakes. If anybody eats rice cakes anymore, back in the day we did. Or you could say, I like that, it's really cool. Okay, so rows by column, it's really cool. Okay, so we talk about a matrix and we talk about the order. We look at the example 10 here from your textbook. Notice that you have just one row and you have 1, 2, 3, 4 columns. So we say the order of this matrix is a 1 by 4. In number 12, different kind of matrix. Notice again it's a rectangle. We look at the number of rows, 1, 2, 3 rows. Number of columns, 1, 2, 3, 4 columns. So we say that this matrix is a 3 by 4. Next one, number 14 from the textbook on page 739. Looking at the number of rows, you have just 2 and 3 columns. So we would say this is a 2 by 3 matrix. And that's order, easy enough. Okay, so how do you get a matrix? Where does the matrix come from? So if you look at, say, the problem number 16, where I have a system of equations, I notice that my x's are all lined up, my y's are all lined up, my equal signs are lined up, and my constants here at the end are lined up. So to draw a matrix from that system of equations, I'm going to make a rectangular array. I look at first my coefficients for the x's. That would be a 7 and a 5. Then I look for the coefficients of my y's, a 4 and a -9. I need some kind of markation for my equal sign. I like to use a line. Our textbook uses a series of colons, but I'm a kind of a sloppy person, so a line is better for me. And then I've got my constants, so 22 and 15. And my friends, you have just made your very first matrix. Very exciting. All right, take a look at number 18, a little bit more exciting. You've got 3 different variables, x, y, and z. Notice that the x's, the y's, and the z's are lined up. Notice in your homework tonight, you won't have them lined up as neatly. So let's go ahead and we'll make ourselves an augmented matrix. Remember, the word augment means to add to. So these are augmented because they have an equal sign on the end. All right, so my coefficients for my x's would be -1, -7, and 3. My coefficients for my y's, looking at my y's, I have -8. Wait a minute, nothing here. The coefficient here would be 0. And for this last y is -1. And my coefficients on the z values would be 5, -15, and 8. Again, using the line there to markate my equal to sign. Looking at my constants at the end, I have 8, -38, and 20. Okay, so you're probably thinking at this point, why in the world would I want to use a matrix? All you did, Glennon, was take a system of equations and turn it into a square with numbers. And you talked about the size. What is the purpose of it? Well, our goal of this is really to work with what's called Gaussian elimination. And Gaussian elimination is great because you can solve a system of equations. When you have Gaussian, G-A-U-S, Gaussian elimination. When you have Gaussian elimination, your goal is to make your square matrix a series of 1s on the diagonal and 0s below it. It doesn't matter what these other numbers are. So I'm just using here an augmented matrix which has 3 variables, x, y, and z. So all those 3 would come together. All right, so this is my goal. This is what I'm going to think about. This is what's called row echelon form. So we'll call that row echelon. And if you're using your graphing calculator, if you go in the matrix menu underneath math, you'll see something called REF, and that comes from row echelon form, okay? So let me just give you a system of equations, and I ask you to solve these it would be 2. What if you had 2x minus 3y is equal to 12? And then x plus 2y equals negative 1. So I come along and I say, hey, I stop you on the street and I say, hey, I would like you to solve those. What are you going to do? Well, maybe you're going to use elimination. And you're going to multiply that second equation by a negative 2. So you'll have 2x minus 3y equals 12. And then negative 2x minus 4y equals positive 2. You would go ahead, you'd add those two together, your variables fall out. You have negative 7y equals 14. And you know right away that y is equal to negative 2. You would take this y value of negative 2, you'd plug it back into your original equation. So you would say x plus 2 times negative 2 equals negative 1. Therefore, x minus 4 equals negative 1. Therefore, x is equal to 3. So we've just solved for x and y using a series of an elimination. That's not hard. You're very comfortable with that. But what if we took this system of equations and we turned it into an augmented matrix? My augmented matrix would then look like 2, negative 3, 1, 2, a line again for our equal sign, 12, and negative 1. Okay, so what if I only worked with the coefficients? So this is what's called Gaussian elimination. I made it a matrix, and I'm going to try to get rid of this 2 and turn it into a 1. And I'm going to take this 1, and I'm going to try to turn it into a 0, just like I have my goal up here. I want 1s on the diagonals and 0 below it. Well, I think the first row operation I could do would be just to switch the first 2 rows. So I'm going to tell my reader, say, hey, I'm going to take rows 1 and 2, and I'm going to switch their spots. So 1, 2, negative 1. And then I'll take this first row, and this will become my second row. All right, great. So I've got the 1 where I wanted the 1. I've met my goal. Now I've got to get rid of this 2. This 2 needs to disappear. So if I could somehow make this 2 turn into a 0. Wouldn't it be nice if I could add wouldn't it be nice if I could add a negative 2 to 2, and that would be 0? That would be very convenient. So what if I took negative 2 times row 1 and added it to row 2? So I'm going to take everything in row 1 and multiply it by negative 2. So negative 2 times 1 is negative 2, plus 2 gives me a 0. Negative 2 times 2 is negative 4, plus negative 3 is negative 7. Ooh, nice so far. Negative 2 times negative 1 is 2, plus 12 gives me 14. Okay? Now notice as I did my row operation, this second row, this is the one that's changing. The first row is not going to change at all. All right, I know that it changes because I wrote that row operation second. All right, so stare at your goal. Think about your goal. My first row has got to be, my first column has got to be 1s and 0s. I have 1 and a 0. I met that goal. My next step is to take this negative 7 and turn it into a 1. How can I take negative 7 and turn it into a 1? Well, why not multiply that entire row, row 2, multiply that by negative 1/7. Okay, again, the first row is not going to change at all. We're keeping it exactly the same, leaving it intact. And moving this down. Sorry, I didn't know if you could see it. I would take 1/7 of that last row. So that would be 0, 1. Oh, that's what I wanted. And then negative 2. That is so beautiful. From this point, then, I could back substitute and change this into an equation. Say x plus 2y equals negative 1, and then y is equal to negative 2. Take this, plug it back in, and then I would get my value for x just like I did up above. Or I could go even a step further, which is what's called Gauss-Jordan. So Gaussian elimination is great, but Gauss-Jordan is even better. All right, so Gauss-Jordan would make this 2 turn into a 0, which would be beautiful. So what if I took negative 2 times row 2 and added it to row 1? Okay, so I'm not going to change row 2 at all. So this is be 0, 1, and then a negative 2 down here below, okay? And so I'm going to multiply negative 2 times 1, which is negative 2 times 0, which is 0, plus 1 is 1. Notice it preserves the 1 there. Negative 2 times 1 is negative 2 plus 2 gives me 0. Negative 2 times negative 2 is positive 4. Positive 4 minus 1 is 3. So right away, I can see that this is in reduced row echelon form, reduced row echelon form, or REF. You see that on your graphing calculator under the matrix menu. Notice I have 1s on the diagonals and everywhere else is 0. And I can say here that x is equal to 3 and y is equal to negative 2. So we just solved one system of equations, both by regular old-fashioned elimination. We solved it using Gaussian elimination and then back substituting. We also solved it with Gauss-Jordan elimination, all 3 methods.